Well, yes, Fernando and Lisandro. I'm Lisandro, and together with Fernando, we'll trying to give a walkthrough the Open Intent Framework repository and what's in it. So let me start by introducing BootNode and ourselves. So at BootNode, we are a team of Web3 builders partnered with the innovators to bring open, decentralized, and permissionless solution. We not only deliver just tech, we stand by our partners on every step of the way by offering full support across strategy, execution, and so. Since 2017, the team has scale measured projects in the ecosystem, including Maker, Gnosis, Aave, Synthetics, Eigenlayer, Drive, Gelato, Hyperlane, and many more. Well, Fernando is a full stack developer at BootNode. He started working on 2014 and moved to the Web3 space on 2017. Myself, Lisandro, I'm also a developer at BootNode. I'm more on the Solidity side, and I've been working as developer since 2006 almost, and I'm in the space since 2018. So let me see. Okay, regarding the repo, you can find it under the BootNode organization GitHub with the name of Intents Framework. And you will see that there is a yarn monorepo with two workspaces, the Solidity one and the TypeScript one. In the Solidity workspace, of course, you will find the smart contract that we developed and that I mentioned before. And in the TypeScript workspace, you will find two different projects. The solver one that contains some abstraction that should be useful for any new solver implementation, and also two reference implementation that we develop using those abstractions for filling intents for our Hyperlane 7683 contract and also echo intents. Then the other one is the UI that contains the app that is being used in the demo and is live, which is based on Hyperlane Warp Route UI template with some little tweaks to create intents instead of sending the token through warp routes. Okay, so talking about the smart contracts. In the Solidity workspace, you will find a founding project with a little tail that instead of using the Gitson module for dependency, it uses a node module. So if you're going to use or hack some code there, have that in mind. And it basically contains 3 contracts that we try to build in some sort of layer, right? The first one, and probably the most important one, is the base 7683, which was mentioned by Eda previously, that implements the interfaces defined in the ERC 7683. And we try to make that contract in a way that will allow supporting different types of order, right? Not just one. Then on top of that base 7683, you have the basic swap 7683 that extend the base contract with logic specifically for a specific order type that we wanted to use or to have like a reference, right? And this order type will allow to swap an input token on one chain for an output token on the destination chain. Then on top of that basic swap contract, there is another one, which is the Hyperlane 7683, which extend the basic swap by integrating hyperlink as the messaging layer for providing proof that are required for settling and refunding. And well, and apart from those contracts on the Solidity workspace, you'll also find some scripts for deploying the contracts and also some others for opening orders on the Hyperlane 7683. Um, well, in the README, you can find instruction for using those scripts, but it basically requires setting some environment variables and running some script using your. Okay, so both the basic swap 7683 and the hyperlane 7683 are, as we said, reference implementation, right? So if someone wants to implement a different order type, like for example, an order type for instead of swapping one token in the origin chain for another token on the destination chain, let's say swapping multiple tokens or probably executing arbitrary messages on the destination chains, then you can replace the basic swag 7683 by your own one. Or let's say you wanted to use a different type of proof instead of using the hyperlane messages, you can replace the hyperlane 7683 with your own logic, right? If you want an example of this, there is an open pull request from the people from Polymer, which is using the event proof from Polymer instead of the hyperlink messages. And I think it's the turn of Fernando.
Okay. Hello. Well, that I have to give an explanation about the TypeScript part. As Lisandro said, there are two major packages there. You have the UI, which is a fork from yeah, it's based on the Hyperlane web routes UI. And it's, as you can see there, it's focused on intents, so it has like a quite some modifications that makes it suitable for intents. And to do so, we have to make this was like a quick period of development. So there we have to patch some dependencies like the SDK from Hyperlane. So if you go there, you will see like a lot of not probably yeah, you can see the patches there that give the result on the application, functional application that you will be able to test. But anyways, we have been working with Hyperlane to make this more standard and functional. So there are two major PRs open, one for the SDK and the other one for the WebRite UI to fully integrate in these standard intents into their UI. But anyways, right now, if you go to the domain that Eda shared, you will be able to see and test the application. One particular thing for you to test it, I don't know, Lisandro, if you can give me the if I can present for a second.
Shall I change?
No, give me a moment. Okay, I will. No, if you can. Okay, sorry. If you can open the web route TS file there, that's a link. If you can, if you not, I can walk people through it later. But if you're not able to share it, don't worry.
No.
Okay, on that file, you will be able to set up your routes. this is like for the demo. What you have, it's a set of tokens that have some configuration for an origin chain and a destination chain, and you can set there two other things aside from the list of tokens and chains that you will be supporting. You can add like a cap to do a maximum transfer depending on the token that you are using, and the other one, it's like the fee that you like to. This is a hard coded fee that you will be able to set up for depending on the destination chain and the origin chain, the route that you define. So the fee will be a fee that the solver will get from this from this operation. So basically, okay, the UI is that it's an adaptation, something easy for demonstrate how the framework functions. And if you can move to the other slide, and we can get a deeper view on what's the solver. Well, this, I think that it's the core part of the TypeScript side. It's an old TypeScript application, and what you have here, it's like it's you have the solver has two main key components that it's split into the indexer and the filler. So the indexer, in our case, in this case in particular, it's they're responsible for receiving the information for the intent being generated, this order that Lisandro has been talking about. And the filler will be the counterpart that will take that order and process it and fulfill the intent. So what we do is a modular implementation. In this case, our current implementation, the one that you will be able to work with, has a base class that it's named base listener, which is just a service that listens to events on a set of chains that you define, process that information and sends it to the filler. And the filler has a set of basic steps. One, it's like the first one is to verify that that the transaction is suitable for the solver. That will be going through a list of checks that is for allow and block lists that you can define. Then a set of rules that will be run against this every order that arrives, and you can create your own rules there for you to decide whether it's a suitable or not order to be filled for the solver. And the last steps will be filling actually the order on the destination chain. And lately, the last one will be the settlement, which is withdrawing the funds on the origin. No, so the flow, it's a user sends some tokens on the origin chain. It will be logged on a contract. The solver application will listen and realize that there is a new order, will fulfill it if it matches all the requirements, and then we'll do the recovery of the funds on the origin. We have videos on. I can try to. I can show. Now see. Yes, let me see if I can share my screen, and I will show you. Give me a second.
Let me try and stop my screen
Yeah,
share.
yeah, but yeah, go ahead.
Okay, done.
Okay, I will share.
Hey guys, you try to, if you share, I can make it go live up on stage.
No, okay, there it is. Sorry. Let me see if you are able to see it.
Yep, there it is.
Okay. So
Cool.
first of all, this is the base application that we use, the DApp that we have used. And here is our adaptation. As I said, it's an easy to adapt and modify. So we did this in less than a day, the changes. The design is not on me, fortunately. We have somebody that has a good eye on the design and people that know how to adapt them. But it was like a day work. Anyways, continuing with the flow, you'll see here I can define an origin chain, a destination chain. This is live now. You can test it. These are main nets. So this is from Marathon to base. I will set one USDC sent to myself. I click on continue. This is run through the Hyperlink SDK, do some checks to verify if the amount is valid and everything on the user side of the equation. You sign it and you send the order. This was the action of sending the order. Now the solver is listening the event. It has already done it. So it did all the checks and did the transfer, no? And I have the funds already on the destination chain. So you can see here the transaction hash on the destination chain where I received this one USDC. And you can see something that I missed to showcase, but on this contract interaction, on the origin chain, you'll see that I sent 1.05, that this 05 is a hard-coded value for the fee for the solver. So this 1.05 is what the solver will be getting on the origin chain as the fee for the operation. And I can, as I said today, if I have a little bit of time, I can show the configuration files for the UI. Here is where you set a top values. This once again is like it's what's a quick development, but it's like quite a standard in the industry. It's like the top max that you the zero address will be the Ethereum address and the Ethereum token. I mean, and ITT it's a test token, but it says here it is saying that a maximum of 100 of ITT, and here is a maximum of 0.01 ETH to be sent. So if you go to the UI and hit max, it will be capped that. In this case, it is set to 50. That's why I have no problem there. But and the other case is here you have the list of tokens where you will see this is in the code, but you will see how the mapping between a token and the different destinations are being built. Obviously, you can reach me out for any details on how to do this or how to tweak it. And finally, this is the definition of fees. But once again, it's a bit convoluted, but once you get time to read it, it's quite easy. If you happen to have to work with any chain that it's not being listed or supported by the SDK, the Hyperlink SDK, you can manually add it here with all the information. This is all warp-route UIs, so you have a lot of documentation there. On the solver part of the equation, now, sorry, you can see here we have the two implementations that Lisandro talked about, the Eco one and the Hyperlink one. The base, here you have the base filler and the base listener. Both of these implementation extend from that and make their own definitions of the business that they are working on with. And each one has a basic structure. And this structure is quite helpful for you to you can see what we have already done, and based on that create your own set of rules and do whatever you need based on the business that you are running on. For instance, one last thing that we did was to create, there. One last thing is to create a script to facilitate this creation of a solver. So you can run this script, and it will create a boilerplate for you to let's say my solver. Obviously, this will be a name. It asks you if you want to enable it by default, and there it is. There you have your my solver with all the basic files and configurations from where you can start tweaking and making your own solutions. This what it does is modify a couple of files to make it the application aware of your newly created solution. And I think that will be all on my side. You can also remove it by just calling the script, checking your solver, and telling it to remove it, and there it is. So I will stop sharing my screen if I can. Okay. And I think that will be all.